Hi, my name is Talia, and I'm a high school senior who loves teaching others chemistry and math. This YouTube channel is a supplemental resource for anyone who might be having difficulty in their chemistry classes. This week, I'm going to be starting a new unit of discussion on compounds, and this week I am going to be talking about classification of matter. So if you need help with that topic, keep on watching, and without further ado, let's get started. Okay, so with matter, we already know that matter makes up all things. It has mass and it occupies space. However, matter can be broken up. And today I'm going to be discussing those different categories. So I'm just going to zoom into this chart. Matter can be broken up into a pure substance or a mixture. Basically, a pure substance means that there's a fixed composition in whatever the substance is, which means it's always made of the same thing. And a mixture contains two or more pure substances, and it does not have a fixed composition. So in one mixture, you might have 60% of one pure substance and 40% of the other, versus in another mixture, you might have 70-30. Now, to break those categories up farther, we have element and compounds in pure substances. An element is everything on the periodic table. Elements are the smallest unit of matter, and they are made of atoms. And like I said, they're on the periodic table. And examples of those include like oxygen, sodium, potassium, calcium, stuff like that. Compounds contain two or more elements. So NaCl or NaBr or LiBr, stuff like that. They're made of two or more elements, and they're also made of molecules. And then for mixtures, we have homogeneous mixtures and heterogeneous mixtures. So homogeneous mixtures have a uniform appearance. They look the same throughout. So for instance, salt water is a homogeneous mixture. And when you look at it, there are no chunks of anything in it. It is all uniform and looks the same throughout. And then heterogeneous mixtures do not look the same throughout. There can be bits and pieces of other things. For instance, a chocolate chip cookie. You've got some dough, you've got some chocolate chips, and that's not homogeneous. So now I'm just going to go over some definitions that are important to know. There's a fixed composition, which I already talked about, which means that it has the same components in the same proportions each time the pure substance is created. So NaCl will always have 1 part sodium to 1 part chlorine. Mixtures don't have these fixed compositions because the proportions of what is used to make the mixture can change. So like for instance, with an acai bowl, you can make some acai bowls with 5 strawberries, some with 10 strawberries. It's not a fixed composition because it's changing. And then we have a fixed set of properties, which means that the pure substance always behaves the same way. So a mixture does not, because the not fixed composition will cause the properties to not always be the same. And that can then affect the behavior of the mixture. So now with that kind of introduction, we're going to go into some examples of classifying matter, and then we're going to go into classification of elements. And we already know that elements are pure substances. First, we have a berry smoothie, which we know is not a pure substance because there's no fixed composition. It is a mixture, and it is a heterogeneous mixture because you can see bits of berry in the smoothie. So I'm going to write that down. So because it's not uniform throughout, it's a heterogeneous mixture. Next, we have hydrobromic acid. This is a compound. First, we know it's a pure substance because there's 1 part hydrogen to 1 part bromine. And because it's 2 or more elements, we know it's a compound. Next, we have Sprite. And Sprite can be classified in 2 different ways, depending on if it's open or closed. So first, we have a closed Sprite container. Now, if you look at a closed Sprite container, it's obviously not a pure substance because there's not a fixed composition, but it is a mixture. And we know that a closed Sprite container does not have the bubbles in it because you haven't opened it and let the gas come through. So it's a homogeneous mixture. And then lastly, we have calcium, which is written like this. And that is just 1 element, which is a pure substance. So that's what I'm going to classify it as. So those are those examples. Now you can try these 4 on your own and then come back to me when you've done the question and we'll go over the answers. Okay, so let's go over these questions. First, we have magnesium oxide, and it is a compound. That is because it has two or more elements. And a compound is also a pure substance because there's a fixed composition. It's 1 part magnesium to 1 part oxygen. Next, we have mint chip ice cream. We know that this is not a pure substance because different recipes of mint chip ice cream have different ingredients and different levels of those ingredients in terms of measurements. So we know it's a mixture, and it's heterogeneous because it's not just straight green ice cream. You can see the chocolate chips or the chocolate chunks within the ice cream cone. So it is a heterogeneous mixture. Next, we have brownies, and this is a heterogeneous mixture for the same reason as mint chip, pretty much, because you can see the chocolate chips or whatever inside the brownie mixture, and there's no fixed composition, so it is a mixture, and it's heterogeneous because there's no uniform appearance. And finally, we have argon. That's an element. It's on the periodic table. It has a fixed composition. Next, we're going to talk about classification of elements. So we're going a little bit deeper into the pure substance realm and talking about how we classify the different elements on the periodic table. So first we have metals, and those are elements that are all the way on the left of the periodic table up until the staircase that's right here in the middle, which we'll also go over. And these metals have their own properties because remember, pure substances have a fixed set of properties. So each kind of element is going to have its own kind of property. So metals are very malleable, which means they can be moved around. They're ductile, which means they can be formed into wires. They are also shiny, and they are good at conducting heat and electricity. So that's everything to the left. Okay, so next we have nonmetals, and that is everything to the right of the staircase on the periodic table. And as you'll notice, the nonmetals have pretty much like opposite characteristics as metals. They are brittle as opposed to being malleable, which means that they can't move. It's harder to move them and bend them. They are dull as opposed to being shiny, and they are bad conductors of heat and electricity. And examples of nonmetals include chlorine, bromine, iodine, everything that's all the way on the right. And then finally, we have metalloids, and that is everything on the staircase of the periodic table. So it includes boron, silicon, germanium, arsenic, antimony, tellurium, polonium, and astatine. And these are kind of like half metal, half non-metal. They have some properties of metals and some properties of non-metals, which means most are good at conducting electricity, which is a property of a metal, but most of them are also brittle, which is a property of a non-metal. And most of them are semiconductors, which is kind of a mix of the two properties of metals and non-metals. As the temperature increases, the conductivity of a metalloid also will usually increase. And that's different than a metal because the conductivity of a metal decreases as the temperature increases. So those are the different classifications of elements. We have metals, nonmetals, and metalloids. And these just further break up elements, which are pure substances. So they add kind of like one more level to that flow chart I showed you earlier. Now we're going to practice classifying these different elements. So give these a try on your own, and then we are going to discuss the answers. Okay, so calcium to the left of the staircase, we know it is a metal. The second one is chlorine, and it is way to the right of the staircase, so we know it's a non-metal. Number 3 is boron, and as I mentioned earlier, that is a metalloid. 4 is silicon, also on the staircase, so it's a metalloid. 5 is strontium, which is to the left of the staircase, all the way in the second group, and that is a metal. 6, we have germanium, which is on the staircase, and it is a metalloid. 7 is also a metalloid, arsenic, because it's on the staircase. Finally, 8, there's a typo, it's a metalloid, tellurium is on the staircase. So those are examples of classifying elements, and that concludes our discussion on classifying matter and elements. This will help in the future, just so you know what you're working with, and it's a good introduction to the beginning of this unit on compounds. So I hope you enjoyed this week's video on classifying elements and matter. Next week, I'm going to be talking about ionic compounds, which will be different than ionic bonds. I discussed in a previous unit how ionic bonds are classified by a difference in electronegativity. So I'm going to kind of further that discussion next week with all different kinds of ionic compounds. So feel free to join me for that video if you have any questions on those topics. I'm going to leave a link in the description box for my tutoring website if you would like to schedule tutoring with me. You can also leave any questions you have in the comments and I will do my best to answer them. I hope you enjoyed this video and good luck with learning the rest of your chemistry.